Hey everybody, welcome back to the channel. So yeah, today we are going to make a tap, or attempt at least. This is not something I've ever done before. And to make it even more interesting, we don't have proper equipment for making a tap. So we're going to be Frankensteining a couple different pieces of equipment together and see what we can do. So just to clarify, when I say from scratch, I mean I'm not making the steel, I'm not hardening the steel. This is a piece of M2 tool steel, already hardened to 63 Rockwell that I got from Amazon, and we're going to be turning it into a 7/16 tap. To make this a little more interesting, we're going to be making a double start tap. I'm going to go through the steps here quickly that we're going to follow to do this. So the first thing I'm going to do is put this piece in the lathe. I have a solid carbide, center drill. I'm going to attempt to center drill both ends of this so I can do any work between centers that I want to. Next thing we're going to do is come over to a tool and cutter grinder, and I'm going to reduce the diameters of this to match my sample 7/16 tap here. Now this is actually 322 thou diameter. The closest collet I have is 5/16, which is 312 thou, and so that tiny difference in diameter is not going to matter. I'm going to make my shank 5/16. Next step is going to be put this flute in here. We're going to grind these flutes in, and the flute's going to do two different things. It's going to create this rake angle on the face of the tooth to make it for a more easy cutting action. It's also going to be a spot where chips can hang out while we're passing through a hole that we're threading. Once we have that done, we're going to come back to the lathe, and now this is where things are going to get interesting. We're going to be using the lead screw of the lathe to create the lead or pitch of the tap. The lathe will be driving the camera leaving fixture, which is going to put a relief on the form of the thread that we're grinding in. The wheel head off of my tool and cutter grinder is also going to be mounted on the lathe, and it's going to have a wheel dressed to the 60-degree angle, and that's what's going to be grinding the thread form into the tap itself. Now, none of those things are meant to be used together. They don't attach to each other. So I've had to come up with some rigging here to make the whole thing work out. And this is an adapter I made that'll allow me to attach my grinding head to my lathe bed and adjust the angle to match the pitch angle of the thread I'm grinding. This is a drive shaft I made, which is going to be run by the lathe, and it's going to power my camera leaving fixture. That's going to keep the camera leaving fixture in time with the lead screw on the lathe. This is some clamping stuff I've had to come up with so I can clamp my camera leaving fixture to the bed of the machine. And then there's some fasteners for putting all this stuff together. And I'm warning you in advance, none of this is precision especially or fancy in any way. I basically just threw all this together to do this experiment. This is the first of many questionable steps where things have to, many questionable steps. Now, I don't believe necessarily that it's imperative that we have a center hole in here, but it is sure going to make a huge difference in what options I have available for work holding and so on. I'm really going to go easy here. I'm not going to force it. Still no center hole. Totally mashed end on this. It's done. I guess this just goes to show us all that not all carbide is created equal. So at this point, I've given up on a center hole in both ends, and in fact, I've given up on a proper center hole at all, and I'm prepared to settle for a little divot in one end of this workpiece so that I can at least stick a center into it and stop it from chattering or flexing. What I'm going to try next is I have a masonry drill bit here, or part of one anyways. I'm going to hand grind the angle to 60 degrees as best I can, thin the web out as much as I'm able, stick that in there, because that center drill did leave the smallest little speck, and if I can get, that is on center, and if I can get this to follow that speck in and create a divot in the one end, that would make me happy. Here we go, attempt number 2 to make a divot. Well, that's got to find its... I'm making a divot.
It's cutting.
That actually works so well that I now have hope of putting a divot in both ends. So I've spun the piece around. I've cut that masonry drill down a bit in length so I can get it deep into my chuck, so there's nothing sticking out to wobble, or next to nothing sticking out to wobble, and I'm going to see if I can't get a divot in both ends. And that's working like a champ. Well, that worked great. I just want to see now, I want to test how that divot interacts with my center on my tailstock. And it's tight, it's happy. That's going to work mint. So I got this setup made off camera. It's nothing fancy. Everything's running true. Everything's on center height. I'm going to start by roughing my shank area down to the 5/16, and then later I'll come rough my cutting area down. Now, I wasn't able to fit a wheel guard in this setup, so what I'm going to do is I'm going to keep my body entirely out of the disc that spinning wheel creates. So if something were to go terribly wrong, it's not going to come flying right at me. Those divots seem to be working as centers just fine. I'm getting a tiny taper here. It's about 2 thou from end to end, so I'm going to adjust that out by rotating my entire setup all at the same time with this swiveling table. There's the shank roughed down to 5/16. It's actually like 2/10 of a mil over, and I did feel, see, and hear this moving around a bit as I was going. So now that I've roughed this down, I'm going to rough this down, bring that to within a couple tenths of a mil, and then I'll finish the whole thing because I really want those centers to be center. So now I've got both areas roughed down within 2 or 3 thou of where I want to finish them. And you can see I've been using a coarse wheel and this finish is really lousy. So I'm going to put a much finer wheel on and take that last little tiny bit off. I have my shank finished now. It's got a much better finish, I think you can see. And I'm very, very close to my finish size here, but I'm going to finish that up with the camera leaving fixture. Here's our next setup finished now, and I'm going to explain exactly what's going on here. I did want to stop for 1 second and mention, you've probably noticed this shank is quite a bit longer than the sample tap that we're working with, and that's because I have limited ways of holding things, and clearance is an issue. So by leaving that longer, that allows me to travel through the areas I need to create this feature. Now, another thing to notice here is I've got 2 sets of tailstocks. One of them I've kept pretty much pristine. The other one is somewhat sacrificial. And if you notice, I've clipped it with different things at different times, and I expect we're going to clip it today, and that's why I'm using my beater tailstock here. I think we're going to end up putting a mark in it here, and we're probably going to put a little groove down the middle of it throughout this process. It might be difficult to see, but I've dished the inside edge of this wheel so that only the very outer edge is going to do the cutting, and then as I go deeper down, the rest will be relief in behind this very edge here, and what that'll do is ensure that I'm getting the angle I want at the tip of my teeth. What I'm attempting to illustrate here is how when I plunge straight down, this wheel is going to create a straight line basically where my little scale is here, and you can see how that straight line passes to this side of center, and it's going to be that difference that gives me my positive rake angle. I don't have a guard on again. There's simply no room for one here at all, but I am going to stay out of that disc that we talked about, and I'll be fine.
I'll be fine.
Everything's going to be fine. Well, this, I'm all done with that setup. I pulled this out of the machine because it was just impossible to see in there, but you can see we have a rake here, or I hope you can see. We do have a rake up the face of the tooth that approximately matches the rake on our sample piece here. And our area that's going to have the tooth, the thread form on it is approximately the same dimension as this that I used as a sample. So the next thing I'm going to do is set up the camera leaving fixture, and we're going to put this lead-in clearance on it. I've got this next setup all ready to go now. What I've done is off of my sample tap here, I've dialed this angle in so we can recreate that as accurately as possible. And I've also dialed in the relief along this lead-in area here so that we're going to recreate that almost exactly. I have one setup to go before we leave here. If you recall earlier, I left just the slightest little bit of extra material on this diameter here. And the reason I did is because I wanted to finish it in here in this camera leaving fixture. So when this actually becomes a tap, this area here is going to have approximately 1 to 1.5 thou relief from the leading edge to the trailing edge. And right now this is round. And so I'm going to go ahead and put that relief on here and then on to the next setup. Don't get close-up pictures of that.
That's sexy.
So that was a bit of a setup, but here we are all ready to go. I've got my camera leaving fixture up in here. And of course it's being driven by this telescoping double U-joint drive shaft, which we're not real proud of. Now the camera leaving fixture is dialed in. I've got it so it's just a 1/2 thou this way from end to end of the tap. What I don't want is the back end of the tap rubbing and causing more grief. I think we're probably going to be pretty lucky if this thing works at all, so I don't want to cause more problems than I need to. Now I've got my wheel exactly at center height and at the angle, the pitch angle of the thread, lead angle, pitch angle. And the reason that I can change this angle and keep my center height is I have the pivot point of this little fixture I made exactly at the center of where this wheel is, or where the profile on the wheel is anyhow. And then of course, wasn't able to fit a wheel guard in. Again, wheel guard guys, sorry, I will not get in the line of this thing. I've got my, we're doing a 7/16 fine tap, but we're doing a double start. And the fine, a regular 7/16 fine tap has a pitch of 20. So since we're doing a double start, I've got my gearbox set to a pitch of 10. So we'll do the one pass down to depth at that 10, and then we'll split that one down the middle for the second lead. I've got this t-shirt taped on here to make as sure as I can that no grinding grit or abrasive is going to get on the ways of my lathe. And this should do the trick. I'm leaving my split nut engaged for this. It's going to actually save me time in the end, and what I'm going to do is I'm going to travel back and forth using the electronic reverser on my motor. Now another thing I've done is I'm keeping tally here of each pass. So far I've made one, and the reason I'm doing that is this is all incredibly counterintuitive. The tool is on the wrong side of the workpiece as opposed to normal threading. It's really weird. There's a lot here that could go wrong, so I'm being super careful and really taking my time. We've made that first pass. I've checked it with my thread pitch gauge. I put a little marker on there so you guys can better see what's happening when we get cutting. So for the time being, I'm going to wind my carriage out here some. I'm going to put my motor in reverse, and I'm going to creep this whole carriage with the grinding head back to the starting position. Put my motor back in the forward direction. I'm going to try a 2 thou depth of cut now, and so I'm writing 3 on here, and what that's telling me is that from my 0, when I get there, this last cut is going to be 1, 2, 3 thou. You can see we're putting that tiniest bit of radial relief on there as we go. This is our first start done, and what I did was I touched off, set a 0, brought it to the nominal single depth, and then when I got there, actually I'll back up. Before I started, I'd measured the diameter of this wheel and recorded it, and after I had ground all the way down to my single depth here, I rechecked my wheel and it had lost only 2 thou in diameter, which I expected it to lose more, but anyways, that's pretty good. So I went ahead and took an extra thou more than nominal off to compensate for that wheel wear, and I think it worked out pretty well. You can see the threads we're cutting are approximately half of the available real estate there, and I think that's looking pretty good. I think if we come back and we split that other flat spot right in half with the second start, I think this should work out pretty decent. To set the lathe up for the second start of the 2-start thread, what I've done is this gear is a 1-to-1 ratio off of the spindle itself, and I've confirmed that carefully. This does have an even number of teeth, which is part of what makes this possible. I've marked one tooth here, and I've marked what it's pointing at here, and then I've marked the exact opposite tooth here. So what I'm going to do is I'm going to pull that gear off, take note of where the keyway is, rotate the spindle 180 degrees, and then fine tune it so that I get this gear back on its keyway while this is exactly pointed at that. We've indexed our spindle 180 degrees without letting the gear that goes into the gearbox move any, and I tested it out by eye there. I looked at it. She sure looks like it's splitting the thread in half to me, so we're going to take our first run across it here and see how it looks then. So I've got that second set of teeth down to the proper dimension, and I've pulled it out. We're done as far as the actual thread form goes, and you can see we're looking, quite a bit like our sample here. Now I did make this threaded portion a little shorter. Again, I had like reach issues and clearance issues. I don't see a problem with this tap being extra long at all, so I'm just going to throw a square on the end of it, and we'll try this sucker out, see what happens. Now I am just going to try this on aluminum for starters, and there is a reason for that. I actually have a plan for this. If this thing works at all in the future, I'm going to use this to make a high-speed steel split adjustable threading die. And actually I will have to do the heat treating on that, so there'll be a bit more of a process than this, but I'm hoping to actually make a set. Break the chip. Going pretty effortlessly so far. Mm-hmm. I think I'm in far enough now. Get my tap handle on there. Well, that's actually cutting pretty nice.
Very nice. Like butter.
Wow. I'm not upset about that at all.
Heck no.
You notice how fast it went through too, that double start, eh? Just okay. Well, I'm plenty happy with those results.
Heck yeah.
After feeling it go through that aluminum, I suspect it'll go through steel, no problem. And so I'm going to source out some M2 for myself, and we're going to use this to make a double start high-speed steel split adjustable threading die. Okay guys, well that's it for today's video. I hope you enjoyed. I mean, I had fun doing this. It was fairly pointless. I just did this for the fun of doing it and to share with you guys. It's not like there's you know, a market for this or anything else, and hope you enjoyed.
Please like, share, and subscribe.
See you guys next time.
Bye for now.